Hello, hello, hello. It's Will. Welcome back to From Bronze to GM and miniKanren. This is episode 12. Today is Tuesday, March 4th. Early start, 6 p.m., 6:01. I'm very pleased. This is the third day in a row making an epi. Very pleased. And I've been happy to see that there have been some comments on Discord and on YouTube. So appreciate those. Thank you. I definitely read them all and I think about them. Sometimes I'll respond directly. There was a comment about the title of Bronze to GM. It's like, oh, do you play competitive games? I play Overwatch. Like, yep. This came from another Blizzard game inspired thing. I don't know if there's like B to GM series for Overwatch. I don't know. I think it's interesting to see the timing, how timing of other events had an influence in popularity of StarCraft 1 and StarCraft 2. The whole thing about how StarCraft 1 became popular in South Korea. And I could talk about that for a while. I'm not an expert in it, but I've heard a lot of people talk about it, and I've read a fair amount about it. But then with StarCraft 2, that I saw more directly because when StarCraft 2 came out, that was when there was a streaming service called Justin TV, which eventually became Twitch. And you could see people playing around with, trying to figure out this whole streaming thing. StarCraft 2 was the first video game specifically designed to be an esport. So it was sort of like the right timing. Anyway, you could see people figuring out things like B to GM. And I hadn't seen anything. I still haven't seen anything before the StarCraft 2 series that were on Twitch. Maybe YouTube. So to my knowledge, at least in English, that was the original B to GM series were from StarCraft 2. There are series and certainly lots of tutorials on Brood War. And Day 9 famously has a series for that came out for remastered for Brood War. But he doesn't call that Bronze to GM, I don't believe. I think it's like, let's learn Brood War, let's learn StarCraft or something like that. And that has a different feeling to me than something like Vibes, B to GM, quite different. I guess some of the things I'm doing or maybe have a little bit of the Day 9 feel. Yeah. Anyway, yeah, this is definitely coming from the StarCraft milieu, if you will. And I just love watching the series. I'm right now finishing up the Silver 1 to Bronze 3 video by Vibe for his 2021 B to GM. He also did a 2019 B to GM. And whenever I'm laddering a Zerg, I've been trying to do what he's been saying. So I started out with the bronze build. Now I'm at the silver build. He keeps adding a little bit at a time. And I'm pretty comfortably low platinum using, I got the low platinum just using like his bronze stuff. I'm stuck in low platinum, but I'm sure as he starts refining things, like, I'm still like, okay, no micro, no scouting other than to see if there's an expansion. But that will easily get you up until low platinum. In fact, I didn't even do that. I got the low platinum, not scouting at all, and just making Hydra, doing that Hydra build. Yeah, you can definitely get to platinum just using his bronze techniques. Okay. But I'm happy to see comments, and it's fine to have a small community of people who are interested and care. All right. Like, All right. I think I saw maybe 4 or 5 comments today. That's a lot. That's plenty. So I was very happy to see that. Thank you. Okay. So one of the comments, I'll leave this, when I'm talking about comments and things like that, I'm mostly going to keep this anonymous. Unless someone asks me to talk about it and wants me to use their name or whatever. But one comment someone made was that they hadn't really thought about design versus research in the same way that I talked about in episode 10. That they kind of feed into each other or they have an influence on each other. So I'm glad that was maybe a helpful sense of perspective. In fact, I didn't even realize I had made quite that point as strongly until I read that comment. But yeah, I think that's it, right? It's like if you really want to understand how a language like Scheme was put together, Scheme in particular came out because the creators of Scheme, the original creators of Scheme, Jerry Sussman and Guy Steele, wanted to explore some research ideas from Carl Hewitt, and they weren't real satisfied with the Lisps they had. So, Scheme was specifically created as a language to do research programming in, for a particular research task that they had in mind. So, that's a very explicit example where research informed the design, like the desire to do research informed the design, right? So that's like another dimension of design versus research. But for things like we're talking about quasiquote, we're going to talk about quasiquote some more today. Quotation and quasi-quotation, these are actually really deep ideas, and you can design languages different ways. Like in ML, there are extensions to the ML language that basically give you quasiquote. And that's tricky in a typed language. I mean, quasiquote is kind of tricky anyway, but in a typed language you have, like additional complications, right? So same with macros, typed macros add additional complications that also give you some additional features that you don't have when you're in a dynamically typed land. But there are all sorts of interesting issues that you can see when you start digging deeply, and like quasiquote came out of logic, like mathematical logic, and logic and philosophy type ideas, and philosophy of language, all these sorts of things. And like philosophy of language, there's a notion of continuations and control effects and all that in natural language. So I remember one thing a friend told me, will also remain anonymous, when I was thinking about going to grad school to study Scheme and study functional programming. I asked this person at the time who was, I think, an advanced grad student. I asked, what's a good reason to get a PhD in programming languages? And he thought a minute and he said, you're likely to become a very good programmer. And I've thought about that quite a bit, right? It's like, and that's a question I ask myself sometimes. Am I a good programmer or am I a terrible programmer? And the answer is, it depends. There is like, hey, here's some JavaScript framework, and a whole bunch of libraries and JavaScript, and, get something working quickly. Well, I'm probably not the person for that, at least on any short time span. You'd be better off probably with a very junior web developer, or someone right out of a boot camp who's had a lot of experience doing that recently. So in that sense, I'd be like a very bad programmer, at least short term. And also, my heart wouldn't be in it. That's the other part. It's like, yeah, I'd probably find it pretty disgusting and I could do it to some extent, and I can learn things quickly, but it would just like not excite me very much, probably. I mean, that's part of the problem of becoming a Lisp programmer, and also a problem with getting to know functional programming or relational programming or logic programs. Like once you've learned certain styles of programs, certain language features, paradigms, things like that, you probably don't want to go back to just doing low-level procedural programming, or like dealing with some language features that are just really nasty, things like that. Anyway, that's part of the problem. Okay, that's that you can at a certain point in time, you're probably not going to want to do that. So that's one issue. But on the other hand, in certain areas, I think I am a very good programmer. For certain types of things. Like that elementary style I was talking about, where I can learn this core set of operators that are compositional, and figure out abstractions and build on it, and then I can get into strengths with my sense of taste, what feels, like the fact that I feel very strong disgust towards certain things, right? Like I think that means I have a sense of taste. That's part of the problem. What comes with a sense of taste? Like if you have a highly developed sense of taste, like certain things just don't taste good to you. And that's true for design. So, but I definitely have a design taste at this point. It took me a while. And that's part of where research comes in. So like the last episode, I was talking about these different trade-offs in unquote splicing. And there's kind of like a feeling for the generalization of unquote and unquote splicing that doesn't give me a good feeling, the way it's done in R6, that generalization. It doesn't have the right taste for me from a schemely standpoint. After a while, there are things that feel schemely. Like after you've really immersed yourself in scheme, there are things that will feel schemely to you and things that don't feel schemely to you. And so there are parts of R6 that don't feel very schemely to me. It's the same with like those Apple human user interface guidelines, the same thing, right? It's like, before I read those guidelines, before I had implemented a number of Macintosh applications on my own and designed the interface and implemented the interface, I was much less aware of the interface design of other applications. And but once I really got into that stuff and read a lot about the design of interfaces and the philosophy of the Mac interface, it was really painful for me to use an application that didn't follow those guidelines or that taste or that sense. It's like, oh man, sometimes there'd be an application ported from Windows to the Mac and you could tell. I mean, it was like, oh wow, they don't care, or they didn't care or didn't have time or resources to convert it. But then there's just like this aspect of, trying to go really deep into understanding the details of the language and going into the history of language features, going to like, where did these ideas come from? What were the trade-offs people ran into? Like, what are all the different ways people have explored quotation? What does quasi-quotation look like in a language like C, like Alan Baldwin's paper talks about? What makes sense? What this goes back to, what I overheard Joe Armstrong talking about. I mean, when he was like talking to a small group, he was saying, it's not like there are good languages and bad languages. It's more like every language has its purpose is designed to achieve, and design desiderata come from that. And then, there are a bunch of choices the language designers made and the implementers made. And do those design choices hang together? Right. So if there's something, if I'm looking at a feature, if I'm looking maybe at an extension for miniKanren or an implementation type thing for miniKanren, or reading a paper on relational programming or constraint logic programming, or looking at some Prolog stuff or whatever, I've got a very strong taste for, a very strong sense of what feels right to me, and which, like largely based on just running into lots of problems. I have a very good sense now of a bunch of problems that you run into when you're trying to do relational programming or constraint logic programming. And what are, like the problems and techniques, those sorts of things, and different design trade-offs and decisions, how those impact like the techniques and the problems you run into and the opportunities. So after just doing that for 20 years or whatever, I can look at a new feature or new proposed feature, and it usually doesn't take me very long to identify if there's an issue, and also doesn't take me very long to break things at this point. Like if someone's got some new miniKanren feature, or a new implementation of something in miniKanren, like I'm very, very good at breaking those things if there's a problem. Because there's like a logic to it. It's like, okay, well, for this to work in conjunction with these other constraints and with this type of search and all these things, then, you had to handle this sort of interaction. Like, how does that work? So you can identify these potential corner cases where it'd be easy to have left out that case or to make a mistake. And then you'll see that there are programming languages that just leave out certain cases. They don't handle corner cases. The sort of the PC losering problem, if you're familiar with that, about, the worst is better paper, if you've read that, worth reading. So, like, for example, and we'll talk about this more, I'm sure, there are lots of languages that have some degree of logic programming, constraint logic programming, relationality. One language is called Mercury, and in Mercury you can write down a relation in what looks like Haskell syntax, something like Haskell syntax, and Mercury compiler will do an analysis based on annotations you've written, stuff like that, and compile your relation to different functions. And we'll get more into relational programming and all that later, but the point is, you write down one type of program that's very general, and then what happens is there are like specialized versions that are functions that get compiled. The general version gets compiled to a bunch of special cases, and that's pretty cool. And there are lots of advantages to that approach. However, one disadvantage is there's like a fully general case that isn't handled by Mercury. At least it hasn't, like it wasn't for a very long time. I don't know if they ever implemented it. There's something in one of the papers or manuals saying like, well, in theory, we could implement this. We haven't gotten around to it. As far as I know, they never did. It's sort of the one case that doesn't fit that model. They just like didn't do. Okay. So those are the sorts of things that, after a while you'll be able to identify that right away. It's like, wait, how are they handling this case? It's like, oh, they didn't. Okay. All right. So you just like can't do that thing. Right. So this is the sort of thing where design versus research, I think, the research can really inform the design, and if you get deep enough in the design, to some extent you are starting to do research. It's like, well, how do these things interact? You'll realize that no one's figured it out before. Or I know with constraint logic programming, there was a type of logic I wanted to implement, and then a friend told me about another type of logic, and it's like, oh, great, we'll just combine those two, and we'll be able to do this cool thing. And then very quickly I realized that no one had ever combined those two before. I was like, okay, now we're immediately at a research problem. We started with a design problem. We wanted to combine these two different constraint operations, and now we're at the point where we're doing like original logic, like original research in computational logic, right? So that's an example of design and research. It comes up a lot, actually. So, it's to the extent where I don't even, I had to record one of those episodes to even remember that there is a distinction, right? I'm just like so used to doing both of these things. Now, and I'll be honest, like most of the time I'm doing design, it's for very small languages or very small features, because like the core of Scheme, I like this idea of having a tiny composable core that you can then extend and build abstractions over. Like, I like that approach a lot. And one reason I like that is the sort of surface area for the design is very small, and you can try to get everything right. Whereas if it's a gigantic language, well, that's going to be really, really hard to get everything to work together correctly. It's like, it's very hard. So, but if you have a tiny language, you can really try to get every single thing right. And, you could iterate over and over and over again. Like the first versions of miniKanren were quite different and quite nastier in a lot of ways. They were way harder to use than current versions of miniKanren. I'll talk about that too, like the sort of the history, the evolution of miniKanren. I think that's a really good case study in the design. Okay. Another thing that came to mind when I was thinking about this design versus research is from the poet and mathematician Jacob Bronowski, who's probably most famous right now for doing a BBC series called The Ascent of Man, which is a really amazing documentary series. Or it's not really a documentary. It's sort of like Carl Sagan's Cosmos, that type of thing, right? It's like one of the expansive. I mean, but it came before Cosmos. Like Cosmos was copied off of The Ascent of Man. It was like the first big travel around the world, show all these locations, but for science. Okay, it's a really amazing series. But he also, in addition to that, and writing books and those sorts of things, he had to make a big choice in his life. Did he become a poet or did he become a mathematician, professionally? Because he was very into both. And in one of his writings, I think it was one of his essays, I'd have to look it up and find it, he talks about the similarity between reading a poem and reading a mathematical proof. And his argument is that these are basically the same at a very deep level, and that there is the person who came up with the poem originally, dreamed it up, thought about it, crafted it, wrote it down, in the same way that there's someone who came up with the mathematical proof and wrote it down. If you read the poem or you read the mathematical proof, you're not the person who created it or discovered it or whatever, but you're the person who comes along later and reads it. There is a process of discovery that you as the reader have to go through. You have to, when you're reading a poem, you have to reinvent that world that the poet is describing. You have to be, imagining things. You have to be attuned to the sense of the language. Like there is a recreation of a world. And if you're reading a mathematical proof, you are similarly recreating what the mathematician who came up with the proof had to come up with. So, you're reading the mathematical proof, you have to understand the logic of it. Why did they have to write it this way? Why couldn't it have been written in a more simple way? Why didn't the obviously simpler way work? Right? Those sorts of things. And at some level, if you really read it deeply and really understand it deeply, maybe you can create your own poem that in some sense is better, or your own proof which fixes a flaw with the proof you read, or is much simpler or easier to understand than the proof you read. But that requires really understanding it at a very, very deep level. So I think it's similarly true that if you are looking at the design of a programming language, you also have to go through this process. Now, it can be hard in looking at a programming language that's old because there's lots that's accreted over time, right? So if you look at R6RS scheme, R6RS scheme, I think that's harder to understand in a way, aspects of it, than maybe looking at R4RS scheme. Because there's just like a bigger surface area and there's a lot of libraries and Unicode and stuff. So that's one reason that I've advocated going back and reading earlier scheme reports that were of a simpler time for a much smaller language and many fewer library library procedures or whatever. You just get a really good sense for the core of the language. And then you could try to figure out, well, why was it done this way? Why wasn't it done another way? And if you look at sort of the core parts of different languages, especially if they're in different paradigms, like you really get the sense of what's different about them in a way that I think is really hard for a very large language, because most of the languages that are used practically in industry are like what I've called these amalgam languages, where they just take a bunch of pieces from other languages that are simpler and conceptually more pure and kind of jam them together in a way. And maybe that works pretty well. It might be a very pragmatic thing. However, it can be very hard from looking at one of the amalgam languages, figuring out where in the world does this stuff come from. And it's like, well, look at the really simple core languages and look at simplified versions of those even. And programming language research was also often this idea of having like a core calculus for the language. Okay. And then you can have, sort of syntactic sugar or decorations that make it more practical. But like lambda calculus. So scheme is based on the call by value lambda calculus. And then there are extensions. It's an extended call by value lambda calculus because it's possible to encode numbers in lambda calculus. However, it's not very convenient or practical from a programming standpoint. It's like extremely inefficient and it's awkward. So I was like, well, technically we don't need it from a computability theory point of view. Although in terms of computational complexity, we would definitely want to have numbers. Those sorts of decisions are important. But the point is, with Scheme, you can look at this tiny little core language and then see how the language builds up abstractions. Okay, so I think that's very cool. Anyway, that's worth thinking about. Oh, okay. Another thing I saw today I wanted to mention was Michael Fogus had a classic post from 2011 that I saw again. I think Fogus has gone back and redone his blog entries to be like plain text or whatever. I think that was the deal. But here's a blog post on 10 technical papers every programmer should read at least twice. And that was a good list there. So talking about this idea that we want to keep reading, okay? We're going to need to keep reading. We need to keep looking at design. We need to keep, exposing ourselves to powerful ideas. And I've also got, for the links, I also have these great works in programming languages collected by Benjamin Pierce, who did some sort of survey. He asked a bunch of PL people which papers they thought were important and influential. And so this list of papers is interesting to see. And then there's like this meta list, classic papers in programming languages, that contains links to a number of lists, right? Okay, so here you go. Just like Hopple, the Hopple series, History of Programming Languages series. There you go. You've got a bunch of Hopple books, right? Go back to Hopple 1 and read some of those papers. Hopple 2, read some papers. Read some papers about languages you never even heard of before. What's the problem they're trying to solve? What are the design decisions they made? Do they make sense? Like, what they learn in history? Often when you read these historical things like, okay, this language is 30 years old, let's tell you what we learned and tell you some of the mistakes we made, right? That's always interesting. So anyway, that's just like Vibe says, it never ends, like it keeps going, right? So we have to keep reading things, keep thinking. This is where we get a lot of our research insights and ideas, and also a lot of our design insights and ideas, right? So I made the analogy, I don't know how you become an architect without looking at buildings other people have built and studying those, right? And that's not like something you study for a semester and then you're done. It's like, no, that's something you continue to do. Same thing here. If you want to, learn about design and become good at design, you want to look at a bunch of artifacts people have designed and try to understand, what the trade-offs are and what the limitations are and opportunities, and which approaches people haven't taken or haven't pushed very far, things like that. Okay, previous ladder practice. So for the micro, the challenge I gave you is the end of R7RS scheme report. Section 4.2.6 has a sentence talking about quasiquote. Unpredictable behavior can result if any of the symbols quasiquote, unquote, or unquote splicing appears in positions within a QQ template, otherwise than as described above. And the challenge was to figure out why that wording doesn't seem to appear in R6RS or R7RS Small. Like, why is that? Does that mean they just changed the wording and they still have this undefined behavior or unspecified behavior? Or did something change where now the implementations are required to check the grammar for these things and, signal an exception? Like, what's the difference? And, I didn't do this. Okay, that's for you to do. So, but if you figure it out, let me know. Okay. But that's a, so this is an example of a design decision. Okay. It is a design decision if you as a language designer say, okay, first of all, you have to recognize that there's unpredictable or undefined behavior. Sometimes you might not even recognize that. But secondly, you have to decide, okay, if there's some undefined behavior, do you want to check for that? Do you want to leave it optional for an implementation to check for it? Or is it required for the implementation to check for it? Is it even decidable to check for it? Like, there may be properties that are computationally undecidable. Do you still require that the implementation checks for it? Or maybe it's decidable but exponential or doubly exponential to check for this property. Do you still require implementations check for it? Those are design decisions. And, like when you get into constraint logic programming, you can totally have constraints that are, doubly exponential to enforce or to check. 2 to the 2 to the n power type thing. Okay. So that was some ladder practice if you want to practice your micro there. And then the macro was read one of the classic Lambda the Ultimate scheme papers from Sussman and Steele. Okay, right? So we always are reading. We're always reading. We're always thinking. And you should have your research notebook, be it electronic or on paper. Write down ideas, write down observations. What are things you're not seeing? Why do you see anything that looks off? Do you see anything that looks like a mistake, or were you like, oh, that doesn't sound like a good idea? All right. And, sometimes you look at a language and you're like, I don't get it. Why do they do that? And then later you'll figure it out. You'll find out. Like when I saw closure, the first time I saw closure, I was like, what in the world? It doesn't have, proper handling of tail calls, but, there's not like automatic tail calls, and, it doesn't have scheme style hygienic macros. And like, there are all these things that I saw that sort of turned me off because I was coming from the scheme background. But then later, when I understood what Rich Hickey was trying to do, it's like, okay, okay. So he was designing for a different use case, and he was also coming more from a Common Lisp perspective. But the main thing is he wanted to commit to the Java virtual machine. He was committing to that host. It was a hosted language. And, he wanted a programmer on a project with other programmers using Java to just be able to drop a jar file in, and no one's the wiser in some sense, or no one has a reason to complain, and that desire meant that you can't do some things that might be nice from a Lisp standpoint that are un-Java-y, okay? Just like I talk about features being unschemely or design decisions being unschemely, Clojure is trying to make sure that its decisions are not un-Java-y or un-JVM-y to the extent where it becomes a problem, and Clojure is not interacting with Java in the cleanest way possible. All right, so that was a really important piece of context I was missing. And then once I understood, sort of the intent and what the preference was, then I sort of said, okay, this is actually a well-designed language. Now, I still have some issues with the design of parts of Clojure, but most of those tend to be small things, or, it's like, well, maybe that's not a problem. Dropping a jar file onto into the project when working with a bunch of Java developers, maybe that's a problem that I don't have right now. That was a problem when I worked in industry. I would have loved it had Clojure existed when I was working as a Java programmer in industry. I think that would have been awesome. So anyway, reading and thinking and critiquing and trying to understand the design, the Ziterata, and what's the problem the language is trying to solve. Yeah. And it's interesting to read about the early history of the Java language and the Java design, and this Oak, this thing called Oak, and Gosling wanted to do something, build something important in 10,000 lines of code, and also Bill Joy, who, was at Sun, wanted the language to be more functional. Okay, so Java could have ended up being a very functional language, but Gosling didn't want that. Maybe he thought that just getting the garbage collection in was enough, or maybe it had been too big a leap for C++ programmers. I don't know. But in any case, Joy apparently made the decision that it's better to have one language designer than to have two people going in different directions. And I think that probably was wise. So I am curious, like, what would have happened had Java been released as a functional language, much more functional language. Maybe it would have been ignored, or maybe functional programming would have gotten more of a boost. As it was, I remember before Java came out, having conversations with C and C++ programmers, efficiency was everything, and the idea of having garbage collection was like ridiculous. And then once Java became established, that conversation changed. Okay. Let's talk some more about quasiquote. Let's talk about quasiquote some more. I was thinking some more about like analogies between things like quasiquote and StarCraft. It's like, why do you need quasiquote? Why is it important to understand quasiquote and to understand it well and to be able to use it well? And I guess one analogy I came up with it is like something like quasiquote you could see as maybe like hotkeys. Okay, so you can play StarCraft without using hotkeys. You can just use the mouse and click on the control card for everything. You can totally do that. And if a pro wants to troll someone, they'll play without the keyboard, right? They'll just play with the mouse. Like, you could do it. It's but if you don't have hotkeys, like it is so painful and so slow and so awkward to do things without having hotkeys. And so quasiquote is kind of like the hotkeys. Like, yeah, you can cons everything up and use quote and all that sort of thing. You can get around having quasiquote using different approaches. You don't need it. Most programming languages don't have anything like quasiquote, so you don't need it. You have a Turing complete language already without quasiquote. However, especially in a language with S expressions, quasiquote's like having hotkeys. Like, you can very quickly and easily, here we go. You can create structures in a way that's quick and easy to do accurately, and that's easy to read, where the S expression structure really reflects what you're doing. Like, if you're interpreting code or doing pattern matching on code, and with the quasiquote and the unquote splicing, what you're looking at looks like the sorts of things you would type in the REPL or in a file if you're just writing the code, if you're not doing metaprogramming. So it lets you do metaprogramming things, but that syntactically look much closer to as if you're just doing regular programming. And you don't have to have that. You could be consing and quoting individual symbols and so forth. But once you've tried doing it both ways, like you definitely want to use the quasiquote. Like, it's like having hotkeys. So yeah, there's just like, if you really want to get good at Scheme, you need to know quasiquote and you need to know how to use it. And you'll see how much we use that in miniKanren programming. Like, we don't have to. And if I'm giving a demo to people who don't know Scheme, or who don't know it well, I'll try to avoid things like quasiquote, but like, for real, I would use it. Okay. And it's great for metaprogramming. You're writing programs that manipulate programs. Quasiquote is great. It's great for pattern matching, all that. And I guess another analogy that came to me was sort of like spreading creep. I don't remember why I was thinking it was like kind of like spreading creep, but yeah, I don't know. Maybe that one doesn't hold as well. But yeah, I remember this analogy. So one question would be like, okay, so there are plenty of people who, if they were trying to do the equivalent of B to GM, they would not be showing quasiquote towards the beginning. They would say, well, that's like a more advanced thing. You don't need to know it. We'll learn that much, much later. And in the case, in some sense, that's true. Okay. And so, like, when Vibe is doing a B to GM, when do you emphasize spreading creep? Because that takes attention, that takes, actions per minute, and the bronze player is already overloaded. But Vibe definitely has bronze level players, spreading creep in the series. And like, I see something like quasiquote in the same way, because, well, in Scheme, we're dealing with pairs and nested lists and things like that. Like these pair structures that can be nested that give you trees. We're building trees, and that's really that's like a fundamental thing you have to be able to do, and be able to do it effectively and quickly and accurately, and be able to read other code that uses this. And so that's kind of like the spreading the creeps. Like, yeah, we could wait until we're in Diamond League and start spreading creep, but it's, if you're playing Zerg in StarCraft, like spreading creep is not optional. Like you have to, like you have to use it. That's like a superpower. And so if you're using a language with quasiquote that's based on S expressions, and where you're going to do things like pattern matching and metaprogramming, like that's not really optional. And so and it's the same thing with the dotted pairs, right? A lot of people say, well, you don't want to show dotted pairs, just show proper lists for a very long time. Same thing there, though. It's like, well, what is a proper list? A proper list is kind of like a lie, and it's like a special type of pair structure, right? Like there are no lists in some sense. It's all these pair things. That's probably not quite accurate in a way, but the point is, like, if you're doing stuff with cons, you're going to start seeing dots at some point, and may as well go ahead and tell you the truth about it so you can understand. That's like the elementary part of it. So quasi-quote and quote and cons and unquote splicing and list, and knowing what a dot is, and knowing the definition of a proper list, the inductive definition of a proper list, and knowing, like the box and pointers, drawings, like how to do box and pointer and go back and forth between these different things. That's like being able to spread creep. Like you have to be able to do it. You have to be able to manipulate and create these pair structures and trees, and you have to be able to read that code and understand what it means. And you have to be able to do it, like it for real. Because if you're reading a paper that has to do with scheme, is probably going to have quasiquote. If you're reading, an expert schemer's code, is going to have quasiquote in it. Like you just have to know it. You have to know what that comma means. You have to know what the backtick means. You have to know what the comma at means. Like you have to, you'll get better at it over time. And quasiquote, like I said, is like its own little micro game or mini game. So I'm not saying that quasiquote is a simple thing. I'm not even saying that quote is a simple thing. Okay, that like conceptually quote is very interesting. It has all these philosophical discussions and design discussions. Like I said, Brian Cantwell Smith, 3Lisp, look that up. And certainly quasiquote is not simple. Okay, it is not simple in the way that, say, quote is simple in scheme. But that's why I'm talking about quasiquote and unquote splicing relatively early on. Like we haven't even gotten to lambda really, right? And so, but I'm already showing you quasiquote. This is not the order that I would introduce things if I were teaching like just like an intro scheme class to say college students, even computer science majors. Like I wouldn't start with quasiquote, and I wouldn't, probably wouldn't start with dotted pairs. But this is like the spreading creep. Like we have to, you have to know how to manipulate these structures. Okay. And so go ahead and start learning quasiquote and getting comfortable with it. And then the other part of it is you need to get comfortable reading the scheme reports and reading the manual, like the Shea Scheme User's Guide, and going off and reading a paper or stuff like that. Like like once again, like that's not, reading the scheme report, like say the R7RS scheme report or R5 or R7 Small or whatever, that is not something that we wait to do until we're in Diamond League. Like, no, we start that in Bronze, right? That's like the spreading of the creep. You have to be reading these things and getting comfortable to the point where you can find things in the report. Basically what's in the report, right? It's like, okay, someone at Bronze level looking at, reading R6RS or reading R5RS, they will understand things and know things at a different level, or notice things at a different level than, say, the Diamond level player or a GM player, but they still should be doing those things. Okay. You can't wait until, you're super high level before you look at the scheme report. Cause like I've said before, I think that you end up in the situation where you have someone who doesn't know how to learn things on their own, just as I've seen with students, just as I've seen with, I've even seen this in grad students. And as I saw in industry, where you have people using a language professionally and they didn't know how to learn anything about the language, right? It became sort of a, I don't know. It's like everything was folklore, right? If you can't read the spec, if you don't understand how to read a spec, that sort of thing, or write little examples and all that, then everything's like folklore. Well, someone told me it works like this. And in particular, not only do you need to be able to read the spec, but you need to figure out when the spec's wrong, or when the spec doesn't match the behavior of your implementation, stuff like that. Okay, that's like the spreading and the creep. You just get better at it, you get faster at it, but you have to start that stuff right away. Okay, that's not something you wait until you're high level. You just get better at it when you're high level, but you're doing it all the time. And yeah. And, I saw a game on Artosis Cast today, StarCraft 1 Brood War game. Artosis Cast, the game where Piano was playing, old school Terran playing, and he was playing a game on Monty Hall, which is this kind of weird map. If you follow ASL, which is now SSL, like you've seen a lot of games on Monty Hall. Monty Hall has this map where, like they're the two main bases for the opponents, and then they're like different lanes that connect the two bases, but there are expansions you can take in those lanes, but there's like a wall of minerals blocking entrance into those lanes. So you either have to mine out the minerals, or have air and be able to drop units in after the wall, or the map was specifically designed so you could use a bug or glitch in StarCraft, the Brood War engine, to kind of glitch units through the wall of minerals. This is one of the great things about playing these old games. It's like there are glitches in the game that people take advantage of when making the maps. And you can do this, like you can do SCV tricks with mineral walking and stuff like that. But there's another trick you can use where if you're playing Terran, if you have a vulture, I get the vulture through the wall, you can put the vulture in a certain spot next to the minerals, float a barracks over the vulture, land the barracks, and if the vulture is moving and in a certain position, when the barracks land, it will force the vulture, it's like a little motorcycle, out from underneath it, and there's at least some chance it will go through the wall of minerals. So you can do that, and you can get your vulture through the mineral wall. And so Piano, who used to be a pro gamer, tried to do this during the game. and Artosis likes Piano. He's like, yeah, Piano is great. But he's not at the same level as the current generation of StarCraft pros. And he just wasn't able to do it. He kept doing it over and over again. So here he is, like spending his time and attention in APM, trying to land the barracks at exactly the right time, and the vulture has to be in exactly right position, moving the right way. I just tried it over and over and over again, and then just like gave up. Right. And Artosis said, well, first of all, that's an example of what I'm talking about, where, Piano's not at the very top level. But he also said that if you're going to be a pro gamer in StarCraft 1, you just have to practice that. You have to just practice it over and over and over again on your own until you can do it. Right. And that's like a great example of what I'm talking about when I say you have to be able to do it. Like you have to be able to use quasiquote. You have to be able to use cons. And what I mean is like at the level of, an actual game on ladder or a tournament game where you have one or two attempts to get it right, or the vulture's not getting through, right? And you might lose the game because of it. You have to be able to do that. You have to be able to do that under pressure. You have to be able to do that, when you're stressed because you're playing a tournament game. And Piano just couldn't do it. Couldn't do that. I'm sure if he tried enough times, he would get it through, but he didn't have 20 times to do it because the game was going on, right? So That's what I mean. Like, it's not that you can use quasiquote every once in a while it works. So it's like, no, you need to be able to read a quasiquoted expression in a paper or code and know exactly what it means and write your own expressions. And then the other example, I also thought it was a great example of like a mini game, right? So you could think of, competitive StarCraft 1 Brood War. There are these glitches with workers and minerals and structures and vehicles like vultures. And like there's that glitch where you can take a barracks and you can take a vulture and you can, squeeze the vulture through the mineral line. Like that's a little mini game. Like you have to, you can practice that and figure out here's exactly where the vulture has to be. Here's exactly, when I land the barracks. And that's something that a pro would practice as a mini game. They're not playing the game of StarCraft competitively when they're practicing it. They're just practicing that one skill or that one trick in isolation until they can do it, repeatedly, or like until they can do that, 75% of the time or whatever it is. You can't be going into a game as a pro in a tournament and try using that technique if you can only do it like 1% of the time or 5% of the time. Like it doesn't make sense. You're better off not even trying it. It's just like a waste of your attention. Get good at something else. But yeah. And the analogy is that there's like a quote quasiquote mini game and scheme. Like quasiquote is rich enough, knowing how quasiquote is implemented, like the expansion algorithm, knowing that grammar, which is not context free, understanding how the unquote splicing works and all those sorts of things, and knowing all these idioms, like from that Alan Baldwin paper, all these idioms where you have like comma at and stuff like that look totally bizarro. Getting up to speed on all those idioms so you feel really comfortable using quasiquote, that's like a little mini game. It's a little mini game. So that's how I learn. I mean, that's how I see learning a language like Scheme really, really well. It's like there are these mini games. There's the mini games of consing up trees and mini games of all sorts of little mini games that you can practice individually and become good at individually, so that when you're trying to do something big, which would be the equivalent of like playing a tournament game, right? High pressure tournament game, you can rely on those individual skills and have confidence in those individual skills, and be effective. So, yeah. So we talked about last time that R6RS has this more general version of unquote and unquote splicing that can take 0 or more objs, as Kent's book calls it. Quasiquote still takes exactly one QQ template, but unquote and unquote splicing are generalized in R6RS. But we've also seen that in R5RS, unquote and unquote splicing, each take exactly one obj, let's call it. And same for R7RS Small. Okay. So, I was thinking, let us decide that we are going to restrict ourselves to the restrictive version of these things. Okay. So, I don't want to, I've never until the other day, I didn't even know that unquote and R6 could take more than one thing or 0 things. I almost wish I could unlearn that, because I don't see any idioms that are necessary, or that require that. And it sounds like maybe it was added more for like an implementation of quasiquote to make it easier to implement quasiquote. I don't know. I don't really understand the rationale for it, but it doesn't feel very schemely for me, because now unquote and comma they're not really the same, and unquote splicing and comma at aren't really the same. So comma at the reader will expand that into a use of unquote splicing, but there are unquote splicing uses that don't have an equivalent comma at syntax. So I don't know, that feels kind of weird to me. That violates one of the nice design principles. So this is what I'm talking about with design, right? I don't like that. So even though I'm using Shea Scheme, which implements R6, I'm just not going to use that. I'm not going to use the unquote and unquote splicing. If I really wanted to to be serious about enforcing that, I could actually redefine quasiquote. So in Scheme, you can redefine syntax. Okay, so I could write a macro that redefines quasiquote and that makes unquote and unquote splicing take exactly one obj each. It's like, okay, now I'm using my own, sort of like special prelude to make unquote and unquote splicing within quasiquote behave as if they were an R5 or if they were an R7 small. I don't really care about it that much. I don't think there's any danger I'm going to accidentally put in 0 or multiple expressions for unquote and unquote splicing. But I don't really see a reason to use the general version. It feels a little weird and icky. I don't understand it. I don't understand the rationale. It'd be very interesting to understand why it was done that way for R6. Yeah. So what I want to do is continue this deep dive. It's not even that deep, right? We're just like kind of poking around into quasiquote history and evolution because I've gotten interested in this. Okay. It's like, well, what's the first version of Scheme that has quasiquote? Was the original Scheme report, did that have quasiquote? Did that, was unquote splicing there the whole time, or was it just unquote? Things like that. Are there Scheme papers on quasiquote? There's an Alan Baldwin paper we looked at, and those examples are in Scheme, but are there other papers, or like Scheme workshop papers? And also there's, my friend Aziz Gulom has this cool tutorial on, building a compiler for Scheme, is quasiquote in there. And there's the Essentials, a compilation book, and the IU course. Does that talk about how to implement quasiquote? You could even look at the Shea Scheme code and see how quasiquote's implemented in Shea. Now, I will say that the Shea Scheme code is not so simple, but maybe quasiquote's not so bad. I don't know. That's probably a bit of a heavy lift. I'm not going to start there, okay? That's probably the last place I would look, although in some real sense, that's going to be a ground truth for how Shea behaves, right? Let's look at that. Let's look at this some more. And because I want to use a real example of something where, I got curious about a language feature. Like to know more about it. I mean, there's more, right? So there's like, Brian Cantwell Smith, 3 Lisp. Does that have quasiquote? There are things like that we could explore as well. So here we are with this tiny little language. I mean, I guess this is the part of the point I'm trying to make. Like, we have cons, car, cooter, null question mark, the ability to quote, a number or a symbol or a Boolean constant. Like we've got a few things like that we've really looked at in any depth. Really, it's mostly like cons, cons and quote, and quoting the empty list or whatever. And now we're looking at quasiquote. So we have this tiny little language, and that part of the language is not Turing complete. It's sub-Turing complete. You can't express arbitrary computation. Like, I've shown you if, and I've shown you some lambdas and lets and stuff, but for the most part, we've been sticking to things like cons and consing up lists and pair structures and box and pointers and all that. And now we're in a quasiquote world. So we're playing this mini game. Okay. So what we've been doing is playing this mini game having to do with S expressions and dotted pairs and tree structures and, lists and all that. And then, finding an element in the list using car encoder. These little operations in a little mini game. A mini game that's a subset of scheme. It's a sub-Turing complete mini game that we've been playing. And my point is we can go really deep just with that tiny little mini game in terms of understanding the design of scheme, the semantics of scheme, understanding implementation if we wanted to. And even things like, okay, so we're talking about things like quasiquote, which are pretty complicated. But then you could look at things like cons. Okay, well, cons looks pretty simple, but in 1976, my advisor, Dan Friedman and David Wise at Indiana wrote a very famous paper called Cons Should Not Evaluate Its Arguments, which is about creating, like streams and lazy structures. Okay, so cons can actually behave differently if you're like in a language like Haskell, right? Like you have a notion of laziness, and that gives you the ability to create different types of structures. So even with something like cons, like, we've got kind of like one big operator, which is cons. Cons could behave differently. And Henry Baker has a paper called Cons Should Not Consus Arguments, right? Okay, so even something like cons, which looks super elementary and maybe super obvious as to what it should do, even there are a whole bunch of different variants. And there's another version called Franz. Instead of creating lists, creates ferns. And, like there's a section on that in my dissertation, but that's something that Dan Friedman had done work on in the past. And, there's Guy Steele has this talk on Dan Friedman Cool Ideas from Dan's 60th birthday Festschrift, which is on my YouTube channel. And he talks about this idea of like ferns and Franz. It gives you like a multi-processing version, and you can actually implement miniKanren using Franz and ferns, right? So like even like this tiny little language we have for like playing the mini game, we're just like consing up pair structures and we can quote some things. Even that tiny mini game, we can do it in all sorts of different ways and get like lazy evaluation out of it, multi-processing out of it. Okay, so it's actually really deep. And if you think about something like lambda calculus is tiny. You have abstraction, application, variable, and we'll get into that later. Okay, but this tiny little language is Turing complete. Turing complete. You can express any computable function with it. And you can also, write down things that don't terminate. So these tiny little systems can have all sorts of interesting structure and interesting design trade-offs. So I guess that's part of my point is like we can go deep and try to understand design trade-offs, try to understand theory, try to understand implementation, try to, look for research questions, even with just like cons and quote and quasiquote, right? It's like that tiny little language, we already have a whole world that we can explore in all sorts of different ways, including really, really deep connections to logic and to, philosophy and natural language and all that. Okay, so that's the sort of thing I like a lot, is this like sort of elementary thing where you're playing around with these little parts. Like miniKanren is tiny. When we get to miniKanren, you'll see how small it is. The core miniKanren has three types of constraint operations. That's it. And we add a couple more, and like every time you add one constraint operation, that like changes so much. Okay. So here's Jacob Bronowski, a little article there. So let's just look at our quasiquote stuff again, okay? So here we go. Remember, we were looking at quasiquote in the scheme programming language. Quasiquote. Here we go. Page 142. Yeah. And we have this infamous obj ... which I claimed the ... shouldn't be there probably. They should definitely be there here and here, but they shouldn't be there on the quasiquote. That's my claim. I think that's a mistake in the book. All right. So let's look at the Shea Scheme User's Guide. So here we're looking at the Scheme Programming Language 4th edition, and here's the Shea Scheme User's Guide. Okay, version 10, that's the version we're using. You have to be careful to not look at version 9, which is what comes up if I do a search, like a web search. I see version 9 or 9.5 or something, but we want version 10. Okay, so this guide, initially at least, was written by Kent, or maybe Kent and his co-workers, but I think mostly Kent, and it also cross-references to the Scheme Programming Language 4th edition. So they're cross-references. So if you see in the index, we're in the index now, if you see a T here, that means that this is an index this is page 216, not in the Shea Scheme User's Guide, but in the Scheme Programming Language 4th edition. So there are actually two types of page references and hyperlinks. Okay, so anything with a T in front of it, that brings you back to the Scheme Programming Language, which is talking about R7RS Scheme. Otherwise, we're getting into the Shea Scheme Programming Language. So let's go look for our friend quasiquote. Here we go. Interesting. Okay, so this is just linking back to page 142. And if I look for unquote, probably the same thing. Yeah, there we go. All right, so there's nothing new, at least according to the index of the Shea Scheme User's Guide, in this user's guide about quasiquote or unquote splicing. They all just link to the Shea Scheme User's Guide, the Scheme Programming Language 4th edition. Okay, well, it's worth a look. And now you know how to use the index, actually, for the Shea Scheme User's Guide. Now, there's one other thing, that sometimes the page numbers are italicized and sometimes they're upright. So what's the difference? So let's look here. The index is unified. This index is a unified index for this book in the Scheme Programming Language 4th edition, TSPL4. Page numbers prefaced by T refer to the latter document. Italicized page numbers refer to the primary description of a syntactic form or procedure. So if it's upright, that's maybe just a mention or use of the feature, but it's the italicized page that actually describes it in detail. Okay, there we go. So there's not a whole lot to know. All page numbers appearing here refer to the printed version of these books and also serves as hypertext links. Okay, so, I have a printed version of the Scheme Programming Language 4th edition. I don't know if I have a printed version of I know I don't have a printed version of the Shea Scheme User's Guide 10th edition. I have printed version of older version. Anyway, there you go. And then we have all the index, so you could see how the index is organized, right? So we have things beginning with punctuation coming first. And then we get into alphabetical, right? And that's different from R6RS index that we saw, where if there's like a hash in front of something, or an ampersand assert or whatever it was, then that's going to be under A, not under the part of the index that has special characters. So the index here is organized differently than the index in, say, R6RS, like the report part, language part of R6RS. So that's part of, once again, you have another mini game, which is looking up information effectively and efficiently about your scheme implementation, about the scheme language, the version of language you're using. You want to know things like how the index is organized and how the cross-references work, and what does it mean when something's italicized, right? That's part of the mini game, right? It's worth reading stuff like this that tells you about the index, okay? And this is, once again, like poor piano, like you don't want to be, you're trying to do some great demo or create something for a class or whatever it is, and you're running out of time and you need to look something up. That's not the time to be looking up like what italicized means in the index. Like you should already know that, because you should be using the index on a regular basis, because you should be looking things up on a regular basis, right? That's my point. It's like you want to practice this. This is a mini game, looking things up in the Shea Scheme User's Guide and knowing that it's cross-linked, to the Scheme programming language, but not vice versa. Okay, so you can go from the Shea Scheme User's Guide, you can click on this to bring you to the Scheme programming language 4th edition, but the index of the Scheme programming language 4th edition does not link back into the Shea Scheme User's Guide. Okay, so that's important to understand. It's like kind of a one-way arrow. So anyway. All right, so there's no new information in the Shea Scheme User's Guide about quasiquote and unquote. It just points us to what we've already seen here in the Scheme Programming Language 4th edition. All right, now we can look up some information. I became curious, like, well, I've barely looked at R4RS, and I've never looked at R3RS or R2RS or whatever. Well, I'm just kind of curious, like what wording there is about quasiquote in, say, R4RS, especially that warning about the unpredictable behavior. Did that come from R4? Like, where did that come from? Because we've already seen that the scheme report will carry over sentences from previous versions of the report. Okay, so here we are. We are at standards.scheme.org. Let's check it out. So modern standards, so we have R7, so links to R7. And then here's R6, okay, great. So this is already kind of interesting. Okay, so here, unofficial documents with errata corrected. Okay, so people have found errors in R6RS. Editor's list of errata. Okay, well, this is interesting. Let's just take a look at this. Okay, R6RS errata. So these are mistakes in the report, supposedly. How about we look at quasiquote? Is there anything about quasiquote? I'm not seeing it. How about just quote in general? If I search for quote, nothing. Okay. Now it is kind of interesting. Like, what sort of errata are there? So here are different sections for R6. Okay, here's one. The term read syntax should be datum syntax. Okay. The sentence contains a duplicate carriage return, which should be elided. Blah, blah, blah. All right. So if you really want to know R6 inside and out, you should, read this and have some notion of kind of what might be important that's different or wrong. and this is not to say these are the only mistakes in the R6RS report. There might be more. Okay. All right, so that's the errata for R6. I'll put that up there. But we also have the classic standards. So we have R5, which I've already told you I like a lot. I like the R5 report. Yeah, here we go. I actually like this. Let's just read this, okay? Oh, when I was really getting the scheme, I printed out a copy of R5, double-sided on a laser printer, and then I put it in a plastic binder, and I just carried that around with me everywhere and just read it over and over again. There were parts I didn't understand, but I read that thing a lot. Abbreviated R5RS, this standard comes closest to the Platonic form of scheme before later standards tackle the complexity of programming in the large with features such as libraries and exceptions and Unicode and stuff like that. Weighing in at 50 pages, the R5RS document is an object of reverence among programming language enthusiasts. Well, certainly among me. It is a touchstone of the scheme community and is considered an exemplar of a concise and expressive language specification in other communities as well. Wow. All right. I thought I was the only one. Okay. What's new? Syntax rules macro. Okay. That's kind of cool. So it talks about the different versions. So we have, here we have syntax rules macros. So this is like hygienic macros, scheme style hygienic macros are appearing in that version. Okay, and then here we have a list of errata. Okay, I don't think I've ever seen this. Errata for R5. Oh, okay. Unofficial documents with the errata corrected. Semantics of call CC. Okay, Richard Kelsey, September 29th, 1999. Well, I can tell you already that there is more than this. There are definitely more problems with this in R5. Like there's some issues with LETREC, for example, that I don't see here. Yeah, great. Yeah, R5 is awesome. Read R5. Read it. Read it. Okay, so here's R5 is 98. Here's R4, 91. Scheme starts really becoming scheme with R4. Hygienic macros were optional and in the appendix. Okay, interesting. So what's different? Syntax rules macros. So here we have hygienic macros, but does that mean they're not syntax rules? I don't know. And here's R3. First scheme report laid on the now familiar tech template. Okay. And then we have early standards. What's here? Okay. So here we have like the really early. So here's the first paper. AI memo. Okay. So I guess it's been backronymed to R0RS, and then revised report, AI memo. Okay, so these are from MIT AI memos. And then revised report, AI memo. And then people from Indiana University contributed to the design of the language. Okay. Well, why do you think I went to Indiana? All right. Yeah, so this is some old school stuff. 75, right? 50 years ago. 50 years of scheme. And then 78, 85. Great. Okay, so these are the old school versions. All right, so I just want to look around here. Okay, and then there are the formal standards. Okay, these are always kind of weird to me. These standard bodies charge for this. Yeah, despite the fact that these standards come from reputable organizations, they are now rarely used and mainly serve as historical curiosities. Virtually all scheme implementers prefer the R7RS series. So, yeah, so this one I knew about, the IEEE scheme. It was withdrawn in 2019, okay? But so it's based on R4 and it incorporates a few R5. Yeah, I don't know. It just wasn't. It didn't get much traction, I think partly because you had to pay for it, and also there was like this community process that was outside of IEEE. So I think it was like largely ignored. So, okay, these two schemes, which I've never even heard of, implemented it. Now there's been a zillion schemes. And then here's an interesting one. Okay, this one I've definitely heard of. DSL, Document Style, Semantics, and Specification Language, 96, DSSSL. Okay, so this was... Yeah, this is like the precursor to XSLT, but it's like scheme-based. Certainly heard of it. I've never used it in Anger or anything like that. Never really read about it. I just knew about it. Okay, so what do I want to do? Well, I want to look at R4. Okay, let's look at R4, and what I want to know, I want to see what it says about quasiquote, and I want to know if it has this weird warning about unpredictable behavior. Okay, so this formatting of this looks a lot like R5. dedicated to the memory of algol 60. Okay, not 91. Okay, let's look at for quasiquote. Whoops, quasiquote. Okay, so these are syntactic keywords, should not be used as variables. Should not be used as variables. Well, that's interesting. I was like, why can't you use those as variables? You should be able to use anything you want as a variable. That's like the modern scheme view. All right, here we go. Quasiquote. You can definitely redefine anything you want. I mean, I guess it didn't say you shouldn't use you can't use them. It says that you shouldn't use them, but buyer beware, I guess. Quasiquotation. Okay, we got some examples. So I bet a lot of these examples are the same in like R7 or whatever. They probably just copied these over. Here we go. Unpredictable behavior can result if any of the symbols appear in positions within the template. Otherwise than as described above. It's the exact same wording. So this sentence was in R4. Okay. Interesting. What about R3? Let's look at R3. I've never looked at R3. Okay, same LaTeX format. Quasiquote again. Here we go. Unpredictable behavior can result if any of the symbols. Okay, so. Okay. So now let's go to the early standards. So let's look at supposed R2RS. Now here, retroactive naming convention. Now we have like R6RS, R7RS, R5RS, but R3RS was the first one explicitly using that naming convention. So these are like backronymed or whatever, given these names like R2RS. It wasn't called R2RS. It was just revise report. Okay, and this is like when people from Indiana are getting involved. AI memo. Let's see, August 85, revised report on scheme and uncommon Lisp. Dan Friedman, my advisor. Okay. All right. Okay, well, I'm obviously not going to be able to search this in the same way. I can maybe look at the index if there's one. It's 76 pages, so this is actually longer than R5. That's interesting. All right, well, we've got a poem here for the abstract. Let's see. I don't know why it's so long. It's kind of weird. Okay, I guess it's got these. Maybe it's got more indexes or something. Yeah, it's still longer. I don't know why it's long. Something's different. Maybe it's the format. It's probably the format. Because it's not 2 column, it's 1 column, so it's probably longer because of that. Pretty sure that's the thing. Okay, so can we find quasiquote, the page number for quasiquote? Let's find quasiquote. QRS. Yeah. Whoa. Okay. All right. I don't see any quasiquote at all. Quotes on 12. So what is this index exactly? It's just index. All right, so page 12 is quote. Let's go check it out. All right, here we have quote of datum is datum. Essential special form evaluates the datum. All right. Yeah. Looks like there's no quasiquote in the revised report. Okay, so in 1985, there was no quasiquote that was part of the report. Yeah. Okay, so looks like R3RS was the first version with quasiquote, and that's where that sentence came from about that behavior, the unpredictable behavior. And that sentence went away in R6. But it's up to you. Part of your laddering homework was that replaced with something else? Okay. Yeah. Okay, cool. I looked at some versions of the report I hadn't before. I will, reiterate, like I believe with all my heart that R5 is like the platonic form of Scheme. Okay, so I highly recommend you read R5, the R7RS report. It's only 50 pages. It's very well written. There are some issues. Okay, it's not perfect, but when you don't have to deal with exceptions and Unicode and all that and libraries, you can have this like really nice core part. And then you can see in something like R6, well, what happens when they added the libraries? What happens when the macro system became more sophisticated? Like, what's the interaction of the macro system and the libraries? Turns out that's complicated. You could start seeing these things, and it ends up being a much more complicated language. Yeah. Okay, and then a couple other things, I wanted to look to see if there was anything here in this Scheme doc / bibliography on GitHub, bibliography of Scheme-related research, right? So this was like from the Read Scheme website. These are all from Read Scheme. So I actually checked that out. Like I checked the repo out, and I used the ACK command, ACK, not to be mistaken for awk. So ACK quasiquote. So ACK is a really handy search, and so I can look for it, and it's like, oh, there we go, Alan Baldwin's quasi-quotation in Lisp. Well, we already knew about that one. So I didn't find any other mentions of titles, at least, that had quasi-quote or quasi-quotation. Quasi-quote. Why didn't it pick up quasi-quotation like that? Hold on a second. Let me try something. Oh, interesting. So there are two versions of the Alan Baldwin paper. It looks like there was a version just on MIT server, and then it was in PEPM, Partial Evaluation and Program Manipulation. So PEPM 99, it was also there. So looks like Alan wrote this up and then, ended up being accepted to PEPM. So these may be different. I'm not sure. But it's got URLs for it, and hopefully those still work. Okay. So that was one thing I looked, but, I didn't see any other papers from like Scheme Workshop or whatever. Another place I wanted to look was in Aziz Ghulam's incremental approach to compiler construction. And, that paper from Scheme Workshop and also the draft tutorial. And then here's Nadamin's repo that has code from her implementation. But, from this tutorial, Aziz's tutorial, let's see, is there anything here about quasiquote? Not seeing anything. How about quote? Back quote. Oh, okay. Interesting. Okay, so instead of calling it quasiquote here, he's just talking about the character as backquote. Backquote. Okay, but quote itself. Let's see, is there anything here in the index? Yeah, this is like very short, I guess. It's not really getting into the quotation or quasi-quote stuff. And then there's Essentials, a compilation. There's like a Python version and also a Racket version. So it's Jeremy Seek. This came out of the course at Indiana, which had been taught for many years, but I guess the most modern version is in Racket, was in Scheme for a long time. And there's here's the IU compiler course on GitHub. And there's a repo for Essentials, a compilation. And if you check that out and run make, and you have, LaTeX installed, like TechLive installed, which I have, then you can actually just build the book. So that's nice. So you don't have to get it from MIT Press. You can just build the book. And here it is, Essentials of compilation. I built it. And let's see, is there anything here about quasiquote? Okay, how about quote? Oh, okay, here we have unquote-splicing. Unquote-splicing, 99. Well, this is kind of interesting because I don't see anything about quote, but there's a use of unquote splicing. So maybe there's something implicitly, probably there's like an implicitly quasi-quoted thing. This may have to do with pattern matching. That's how it used to be done with the pattern matcher in the IU course, is that there was like an implicit back quote you would use, and then you would use a comma or a comma at. So I don't know. What if I search for comma at? Okay, so here, oh, no, here's a back quote. Huh. I'm a little confused. Okay, so there's definitely uses of quasi-quote that are explicit, because in Racket, with the pattern matcher in Racket, you have to do it explicitly. The standard IU scheme pattern matcher, the quasi-quote's implicit instead of explicit. Okay, well, wait. Is there like an index here? Let's look this up. I'm a little confused because when I was searching for quote, oh yeah, by the way, this is Aziz's paper. Incremental approach to compiler construction. Okay. Yeah, where's index? $223. Oh, come on. Here it is. All right, what am I supposed to look for? Okay, I'm a little confused here. I expected... There's no quote or quasi-quote listed here. There's just like the unquote splicing. Huh. Maybe quote's not talked about at all. It's just sort of like, here's the syntax for the pattern matching. Well, in any case, there's certainly not a description of how how to implement quasi-quote or anything like that in this book, as far as I could tell. All right. Yeah. Well, I think those were all the resources that I was thinking of looking at. I mean, like I said, Brian Cantwell Smith's 3Lisp, if you're interested in how quotation can work differently than it does in Scheme, right? So quote can work differently, quasi-quote can work different ways, cons can work in different ways. Even this tiny little mini game, this tiny little sub-Turing complete language, we have all sorts of design variants that we could explore. Yeah, interesting. And then even just like representing quote of cat, how does the resulting symbol you get back from, Scheme, if you do quote of cat, in Scheme you get back cat. You don't get quote of cat. In Racket, if you try this by default, you would see quote of cat, but my understanding is that's more like a printing thing. It's still like the symbol cat. In 3Lisp, I think you literally get back quote of cat. Quote of cat evaluates the quote of cat, which is a list, not a symbol. That's my limited understanding. I've never looked deeply at 3Lisp. That might be something to do at some point. But anyway, we're already in research territory with this tiny, tiny little language with cons, quote, quasi-quote. You can riff on all those things all day long and explore new things, go look at the literature, connections to philosophy and mathematics and natural language, right? So it's like already extremely rich, not to mention like how you implement these things. So one thing I would like to do at some point to better understand the quasi-quote would be to implement the algorithm at the end of Alan Baldwin's paper and maybe look at the Shea scheme implementation. Okay. Like I said, the Shea scheme code is often pretty complicated, and quasi-quote is already kind of a complicated operation. I've never looked in the Shea scheme code for the implementation on quasi-quote. Be interesting to look at. Yeah. Same with Racket. Could look at that. I suspect both implementations, even finding where they're implemented, like, that might not be completely obvious where to look. And maybe we can dive into that at some point. But, that one I don't think we need to do right now. Okay, that one we can hold off on a bit. If you feel brave, go for it. Go for looking at the Shea code, looking at the Racket code. See if you can see if you can at least find where quasi-quote's implemented in both. But I would like to implement the Alan Baldwin algorithm and see if we can recapitulate the behavior and scheme and try to understand what in the world's going on with this unpredictable behavior thing. And does Baldwin's algorithm suffer from that unpredictable behavior? And what happened, for R6 and R7 Small, does the Shea scheme have unpredictable behavior? Didn't see anything about it listed. So I guess that problem has been resolved, but I don't know how, or I don't know what the problem was to begin with. Anyway, very interesting. And I would like to implement that at some point, but not yet. Not yet. So we need some ladder practice, some micro and some macro. Okay. So for the macro, read R7RS. Read it. Read it. If you haven't read it, read it. If you have read it, read it again. If you read part of it, read some more. Oh, I love it. And think about what's missing. think about what's missing. In the context of a modern programming language in the large. Yeah. You could also read about other versions if you want, but read R4 or read R3 if you want, but read R5. For micro, practice consing up lists and pair and tree structures. And practice your quasiquote and unquote splicing. Okay, so at this point, I shouldn't have to give you a bunch of exercises because you can go and look at the scheme reports. You can go and look at the Shea scheme programming language 4th edition. And there'll be examples. So run those examples and play around with them and riff on them. Say, okay, come up with your own examples. Start coming up with your own examples. Okay, and practice this. Okay, practice this. And you want to be able to do it for real. Okay, want to be able to do this for real. So practice it. This is no different than going on to StarCraft and playing against the computer on the easiest mode to just practice some minigame aspect. Okay, it's the same thing. And as Vibe says, some people say, well, I just want to play StarCraft for fun. Okay, I don't want to have to study it or practice any builds or practice spreading my creep or worry about the hotkeys for queens or injects or whatever, right? And Vibe's like, yep, if you just want to play for fun, have at it, nothing wrong with that. Same here, right? It's like, hey, if you just want to, poke around and play with Scheme a little bit, get some sense of what a Lisp is like or that particular Lisp, have fun, no problem. If you want to get to the point where you can write complicated Scheme programs and read complicated Scheme programs and, do it quickly and accurately and be able to prototype, interesting ideas in short periods of time and read a research paper and understand it quickly, then you need to know how to do these things. You need to, you need to know your little micro tricks with quasiquote and unquote splicing, and ideally learn some of the idioms in that Baldwin paper, or at least be able to recognize that there's some interesting, if you see something that's quasi-quoted and you see comma at, it's like, okay, this is like an idiom. Okay, what does that mean? And you could also look at the Alan Baldwin paper or look in the Shea Scheme programming language or do experiments on your own, right? You want to get to the point where that's something you can do. And, it's not, you're not going to get frozen. It's like, oh, what in the world is that thing? Yeah. Okay. Well, I think that's it for today. Hope you have a good one and hope to talk to you soon. Bye-bye.